and good afternoon, everybody. So in this talk, I will try to show you our survey done with OmegaCam has really triggered many interesting results. And one of them is the discovery of a colossal relic filaments of star formation. And this is work which is mostly done with my colleagues Giacomo Beccari and Teresa Gerard-Cueva. So the main motivation of the work was really some very fundamental questions. And the first one is, how do stars form? Okay, on which scales do they form? Do they form in small clusters or do they form on much larger scales? And is star formation happening in bursts or is it happening continuously? And another question that we are wondering is, how do planets form? And this is because the way planets form will depend a lot on the properties of the disk around the star. And in particular, it is the time scale of the disk dispersal that is an upper limit to the time scale for planet formation. So we want to know what is the lifetime of those disks. And we want to know if this depends on the environment. And of course, we already have some clues, and in particular by the work by Lada and Lada, we think that we know that a majority of stars form in clusters, and those clusters are short-lived. 90% of them may be dissolved within 10 megayear, and only a few percent will survive for more than 100 megayear. The problem that we saw is that in close-by star-forming regions, most of the study concentrate mostly on the inner part of the clusters, the most dense ones. So there is a region of the high stellar density. And this can lead to biases, because in fact, in these regions, the disk disruption is driven by environmental effects, like a rapid disk erosion or dynamical interactions between the disk. And these conditions are unlikely to be representative of the formation conditions of the majority of stars. And here is an example by Esther et al., where they show the cumulative probability distribution of disk around stars, and they compare various different star-forming regions. And so this is, of course, very interesting. And in principle, you can see that there is some difference between the ONC and Taurus, one having a smaller disk than the other. The problem is that if you look at what is done in the ONC, it corresponds only to this very inner region, central region of the Orion Nebula. And so is this really representative of all star formation? And so we thought it was imperative to extend the studies of this population to include much wider region of diffuse star formation, and therefore cover, in fact, several tens of square degrees around those star forming region. And this is what motivated Giacomo Beccari and his colleagues to do the ad hoc survey. So this is the accretion disk in H alpha with OmegaCam. So this was done obviously with OmegaCam, and in fact is using those filter sets. So basically UJI, H alpha, and also the Z band. So this is mostly similar to what we just heard, the VVAS Plus survey. And indeed, the strategy that was followed by Giacomo was similar in terms of observing both the covering the sky, but as well as the exposure times as the VVAS Plus strategy. In total, there were 355 Ors, which were allocated to several of those programs. And this allowed to cover really several tens of square degrees around 8 star-forming regions, which are shown here. And so this is an example of the sky region, which is around in the Orion region. So you can see that it covers about 100 square degrees. And by comparison, this is now where the Orion Nebula is located. So we have a much more area. So now we are really talking. And the advantage of this ad hoc program, which is a deep and homogeneous photometric study of prime sequence star, is that it also includes this H alpha. And so this means that it can study if there is H alpha excess emission in the spectrum. This is likely to be linked to ongoing accretion. And so it can allow us to study the presence of disk inside those star-forming region on very large scales. And so you will most likely hear a lot about these surveys in the coming months and also in the next two talks. But what I'm mostly interested in is in this serendipitous discovery. And so this is the Orion Nebula cluster, which was studied with Gaia-DR2 and this Omega Cam survey, and you will hear more about that from Teresa's talk. But when we looked into the proper motion plane, which is shown here, so in alpha and delta, so this is the ONC region, we could see there was a little cluster which was there. And so when we look on the sky, it looks to be, in fact, very spread out and not at all compact. And we then extended the area to a much larger region of 15 by 15 square degrees using Gaia-DR2. And we did a clustering algorithm, DB-scan analysis on it. And this is what we found. So you can see that we recover many clusters here. But in the proper motion plane, we also then recover this strange population, which is spread out over the whole region. And when we look at the color magnitude diagram of those populations, this is the first one, the one obtained with Omega Cam for the smaller region. So the R minus I versus R. You can see that it's well-defined population, but which is in fact shifted compared to the ONC. And the same when we extended this region with Gaia data. So in fact, this is a region, so it's a population of star which is older than Orion, which is 15 to 20 million old. And so this means that we discover a relic filament over a region about 90 parsec, which is the extent where we discovered that. So in a sense, this is not a surprise because we do know that star forms in filament. There has been many studies done in the radio, submillimeter, and infrared that show that indeed molecular clouds are spread out over filaments, which can be up to tens and hundreds of parsecs, and the same with AMA data. So can we find another example of such a relic filament? And so we looked at another region, which is the region Villa OB2. And there again, we had the ad hoc data about this. So it was a 50 square degree around the bright star Gamma Duvel, and we applied again the clustering algorithm on this region. And this is the result. So this is here on the sky, RADEC, and this is a proper motion. And in fact, in total, in this region, we could identify 6 clusters. And one of them we only identify in proper motion because you can see this is so then it is very spread on the sky and it's not as compact as a cluster. So, and when we look at the color magnitude diagram from Omega Cam with those population, we can see that they've defined 2 well-defined sequence. And so we have in fact 2 population, one which is 10 megayear old and one which is 30 megayear old. And when we look at those stars here for which we have the radial velocity, we can also see that they differ by the average velocity. And they are very well defined also in parallax. So we then decided again to look at a much wider region around this this region that we studied with Omega Cam, this time using only Gaia-DR2. And what we found was further away, we found a new cluster, which apparently nobody had found before in the Gaia data. So this is how it looks like in proper motion, and this is how it looks like on the sky. So it is very well clustered, and we call it BBJ1. And so this cluster is very well defined. And in fact, when we look in the CMD, it has exactly the same age as one of the other clusters that I mentioned before, which was NGC 2547. So it is coeval to this one, but it is in fact located 260 parsecs away. And so we found that this was very interesting. But then we applied, again, this clustering algorithm and looked for all the populations. And what we found is that looking around, we can indeed identify a set of stars which are all 10 million old and which share similar proper motions. And we find then a major set of clusters which are 30 million years and which are connected by loose stars in the whole region. And we also found two new clusters, BBG2 and BBG3. And again, when you look at the color magnitude diagram, they are very well defined and they occupy the same region. So we have indeed two populations of stars here in the same region. But what is most interesting is that this one, which is coeval, is indeed a large coeval structure which spans more than 260 parsec. So it's a colossal stellar relic filament. And we have done the same analysis now with the new Gaia data, the DS3, and in fact, it becomes even more impressive because now we have even more clusters that we can identify there. So we have now 32 clusters which were found in this region, 26 which have the same age of 30 megayear, and 6 which have 10 megayear old. And so we can just see an ensemble of young stellar clusters which are just getting out of the original filament from which they were born on a very large scale. And so this is my takeaway. Large survey allows us to uncover really star formation on unique large scales. But of course, now we need to follow those up with larger surveys, trying to do photometry and spectroscopy of those objects in order to characterize and prove that indeed they come from the same population. Thank you very much.